Welcome to the session on forces and motion, review exercises. The objectives for this session are to review previous topics through exercises, namely, add two vectors, find the missing side and angle in a right-angled triangle, and use the formulae for constant acceleration in order to solve problems. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. Suppose AB and BC are vectors, then AC equals AB plus BC as shown. Let's now have a go at review exercise 1. Suppose a boy walks from A to B and then from B to C. If AB equals 8i plus 4j and BC equals minus 3i minus 8j, find AC. So here's a little sketch of what we have. And since we have that AC equals AB plus BC, we simply add the vectors. Here's AB and here's BC. We group the i's together and the j's together to give us 5i minus 4j. Before we move on to the next exercise, let's remind ourselves of Pythagoras' theorem. Consider a right-angled triangle. The length of the hypotenuse equals c, and the length of the other two sides equals a and b. And therefore we have that a squared plus b squared equals c squared. This is Pythagoras' theorem. So let's take a look at an example. If we have what we call a 3, 4, 5 triangle, as shown, then 3 squared plus 4 squared equals 5 squared. So here's 3 squared, here's 4 squared, and here's 5 squared. Now let's consider review exercise 2a. Find the length of the hypotenuse in this triangle. Using Pythagoras' theorem, we have that 2 squared plus 3.5 squared equals x squared. And therefore, x squared equals 16.25, which implies that x equals 4.03 centimeters. For part B, we require trigonometric ratios. In a right-angled triangle, the three trigonometric functions are given on your screen as shown. So let's now take a look at review exercise 2b. Find the size of theta in the given diagram to 1 decimal place. So in this triangle, we know the opposite side, or the length of the opposite side, which is 2 centimeters, and we know the length of the adjacent side, or the side adjacent to the angle theta, and we are required to find this missing angle theta. Since we have the opposite and the adjacent, we need to use the formula for tan, so tan theta equals opposite over adjacent. And so if we plug in the values, we have tan theta, which is of course unknown, equals 2, which is the opposite, over the adjacent, which is 3.5. And rearranging this gives us that theta equals tan inverse of 2 over 3.5, which implies that theta equals 29.7 degrees. Before moving on to the next exercise, let's remind ourselves of some standard notation and some formulae. So the following letters are used for an object moving in a straight line with constant acceleration. We have s equals displacement, u equals the initial velocity, v the final velocity, a the acceleration, and t the time taken. And here are the formulae which we derived in previous sessions. So let's now take a look at review exercise 3. A particle starts from rest and accelerates at a constant rate of 2 meters per second squared. Find the velocity of the particle after 5 seconds. After 5 seconds, the particle decelerates at a constant rate of 0.5 meters per second squared until it comes to rest. Find the distance the particle travels whilst decelerating. So let's draw a diagram of this first. Here's our particle. The initial velocity, u1, for the first part of the journey is 0 meters per second because the particle starts from rest. It then accelerates at a constant rate of 2 meters per second squared. So a1, which denotes the first part of the journey, or the acceleration for the first part of the journey, is equal to 2 meters per second squared. We're required to find the velocity of the particle after 5 seconds. So t1 equals 5 seconds. The final velocity, v1, for the first part of the journey, of course, is what we are required to find. For the second part of the journey, we have that the acceleration, or a2, equals minus 0.5 meters per second squared. Notice that the particle is decelerating at 0.5 meters per second squared, which means its acceleration is minus 0.5 meters per second squared. The distance it travels, s2, is what we're looking to find. And of course v2 is equal to 0 meters per second because it comes to rest at this point. So just to re-emphasize, subscript 1 denotes the first part of the journey. And notice that the final velocity for the first part of the journey is the initial velocity for the second part of the journey. And of course, subscript 2 denotes the second part of the journey. So let's solve the first part of this exercise. Notice that this focuses on the first part of the journey, and this is why we've shaded out the second part of the journey and focused on the first part. Furthermore, in this part of the journey, we have the value of u and a and t, and we are required to find v. S is not involved at all in this scenario, so we only use the formula without s in it, and this formula is v equals u plus at. So this equation, when we input the values, implies v1 equals 0, which is the value of u, plus 2, which is the value of a, times 5, which is the value of t. And of course, this gives us that v1 equals 10 meters per second. Now let's take a look at the second part of the exercise. For this part, we need to focus on the second part of the journey. We've just calculated that v1 equals 10 meters per second. This, of course, was the final velocity for the first part of the journey, but it's also the initial velocity for the second part of the journey. Therefore, u2, which is the initial velocity for the second part of the journey, equals 10 meters per second. So notice that we have the value of u, we have the value of a, and we have the value of v. However, we're required to find the value of s. T is not involved in this scenario at all. This is why we're going to use the formula v squared equals u squared plus 2as. So plugging in all the values, we have 0 squared, which is the value of v, equals 10 squared, where of course u equals 10, plus 2 times the acceleration is minus 0.5, times s2, which is what we're required to find. And so rearranging this equation and tidying up gives us that s2 equals 100 meters. This brings us to the end of this session. If you have understood its contents, you should be able to add two vectors, find the missing side and angle in a right-angled triangle, and use the formulae for constant acceleration in order to solve problems. Thank you very much for listening.